Hello. Now, when you first got your Electron, I should think the first thing you did was to go through the programs on the introductory cassette. And they will have given you a good idea of what the machine is capable of. Graphics, text, and colors. And you'll have had an introduction to the facilities built into the keyboard. Now, also with the machine, you had two books, the user's guide and a book on programming. And I'd imagine that you've been through those, at least casually. Now, what we're going to do during this videotape is to start at the beginning with how to write a program. And we'll cover not only the basic statements that are involved in a program, but also some of the ideas behind designing a program. Because the better designed a program is, then the more effective it'll be when it runs, and the easier it is for you to change it. But before we start working with basic statements, let's have a little introduction to the machine itself and what's going on inside it. Now, your first reaction might be to start with the keyboard, looking at the letters, the symbols, and the words that are printed on it. And of course, we'll have to go through those as we go through this videotape. But it's more important to understand what's happening in the memory of the machine. So before looking at the keyboard, we'll see what happens inside your Electron's memory. Now, if we imagine that this is the memory of your Electron, there are some important things inside it. Now, the first area we'll call the MOS, the Machine Operating System. And this is a program that's permanently inside your computer, whose job it is to control the computer, and the cassette player, and your television. Now, the next thing is called the Basic Interpreter. And it's the job of the basic interpreter to understand all the instructions that you're going to put into your program. Every instruction you write has to be correct and understood by this basic interpreter. So these two programs are always inside your machine, even as soon as you switch it on. And the next thing is your program itself. And that's what we're going to be concerned with during this videotape. Writing the statements to go into this part of the computer's memory, which will be interpreted and understood by the basic interpreter. And as the main part of your program will be outputting information onto the screen, onto your television screen, then the last part of memory is allocated to the screen. Your program will put information into this part of memory. And because the information has been put there, it'll then appear on your television screen. So those are the four main things that are inside your Electron's memory. And what we're going to concentrate on is this one, your program. Now, a basic program is a series of statements that you will write. Now, within those statements, there will be certain special words that are known to BASIC, that have a certain meaning, words like print or read. And there'll be other words that you've made up. They are names that the programmer defines for himself. We'll start by looking at a section of a BASIC program, and we'll see how we can change it, add new lines of statements, and delete some lines. When we've done that, we'll go on to designing and coding a complete program. But let's start with this coding. Now, I've got a small program inside the computer, and I'm typing LIST, followed by the return key, so that we can see a listing of this program. As you can see, there's a whole series of lines forming the program. And although they're not very clear at the moment, you can see numbers at the beginnings of these lines. Each of these lines is one basic statement. Although it's possible to put many statements onto a line, to keep it simple, I've left only a single statement on each line. Now, so that we can see it a little more clearly, I'm going to use another option. The list statement simply gave me a list of all the statements in my program. I'm now going to use listo, L-I-S-T-O, followed by a space and a 7. That has no effect, but if I list the program again, you'll see it's much easier to understand. I'll list the program again, and you can see that we now have some extra spaces after each of these numbers. And also some extra spaces have been put at the beginnings of some of our lines. And we'll see later how useful that can be. So, our first two commands. A list command allows us to see on our screen all the statements in our program. And a listo 7 command gives us these extra spaces to make the listing easier to read. Now the numbers you see on these lines, 10, 20, 30, down to 160, go up in steps of 10. That's not necessary. They could go up in steps of 1, or there could be different gaps between each line number. And when we look at putting new lines into a program or deleting lines, you'll see that it's often useful to have steps bigger than 1 between these numbers. So each of these is a statement. That one starts REM, a REM statement. That one repeat, until, end, CLS. In this example, all these words in capital letters are special words that are part of the basic language. And I've used small letters for things that I've invented, for my own names. It's not necessary, but it makes it a lot simpler to look at the program and see which are the basic words, the key words as they're called, and the words that we've invented. Now suppose we've started to write a program and we've written 16 lines of coding. We might want to change it. We might want to add new lines into our program. We might want to delete some lines. We might want to change a line that's already in the program. So in order to see how that works, we'll need to look at the screen and the keyboard at the same time. Now, as all the lines in that program had line numbers, to put a new line into the program, we need to start with a number. Let's use number 15. And I'll just type hello. 15, hello. That line hasn't been put into the computer yet, because I haven't yet pressed the return key. My little flashing line, the cursor, is still waiting after the letter O. Now, if I press the return key, that new line, 15, has been put into the program. Let's list the program again to make sure that it's there. There's line 10 that was there before, line 20 was there before, but our new line, line 15, has gone in the right place in between them. So, to put a new line into a program, all we do is give it a number, and as soon as we enter the line, it's put into the right place in the program according to its number. But there's another important point to note about this. Hello isn't a valid basic statement. When you put a line into your program, your Electron doesn't check it to make sure it makes sense. I can type any sort of rubbish in, and as long as there are line numbers at the beginning of it, they'll be accepted and put into my program. Only when I try to execute that program, when I ask my Electron to obey all those statements in the program, will it discover that hello is not a valid statement. So you need to be careful when you put lines into a program that you do type valid basic statements. Now, in the same way that we use a number followed by a line of basic to put a new line in, we can remove that line again by using the same number, but nothing after it. If I want to remove line 15, I do it like this. If I enter the number 15 and then press return, Basic sees that number, 15, and so knows it must be a line number. There's nothing after that 15. I pressed return immediately. And so Basic understands that to mean that line 15 should be removed from the program. If I list again and press return, you'll see that 10 and 20 are still there, but the line that was in between them, line 15, has been deleted. So it's very easy to put a new line into a Basic program. We simply type the line number and then the line of Basic that we want to use. And it's also very easy to remove a line from our program. We just type the line number and then press the return key, and Basic will remove the line from the program. But if we want to change a line, it's a little more complicated. If we've got a line that has a mistake in it, we could just retype it again from the beginning. But we can use some editing facilities that the Electron gives us. So we'll look at those next. Let's suppose that we wanted to make a change to this line, line 150. Now it's quite a long line, so perhaps we wouldn't want to type the whole line again. What we'll do, instead of typing the line afresh down here, we're going to copy the text that's in this line down to here. And to do that, we use some special keys that are on the right-hand side of the keyboard. A left arrow and right arrow, an up arrow and a down arrow. One key that's marked copy and another one that's marked delete. Now the delete key is quite simple. It deletes the last character that was entered. So that if I enter 1, 2, 3, the delete key will wipe them out again. Now my cursor is here at the moment. I'm going to have to move the cursor up to this point to start copying the information from this line. So I use the up arrow key. Now I've pressed it once. You can see what's happened. My little flashing line that tells me usually where my next character will be entered has moved up a line. And in the place where it was is a large white square. If I press it again my flashing line moves up and this square stays in the same place. Now my flashing cursor is on the line I want to copy. If I press the copy key, and each time I press it, the character that's above this flashing line is copied onto the line where the solid box is. I've copied 150, a space, and the letter P from this line. If I keep pressing the copy key, I can work my way along the line. Now let's suppose I wanted to change this 5 to a 4. I've already copied the 5, but I don't want it. So I can use the delete key to rub it out. My white square moves back one space, but my little flashing line stays in the same place that it was. I can now type 4 using the 4 key on the keyboard, and that 4 is entered in my new line. If I continue to copy, the copying procedure continues as before. In fact, if I hold down the copy key, it'll repeat automatically. I've now copied the whole of the line. When I press return, I've now typed in a new line 150. And that new line 150 will replace the old line 150. If I list the program again, you'll see that the new version with a 4 in that position has replaced the old version with a 5 there. As you can see, our new line 150 with the change in it has been copied into the program and has replaced the original line. So if we have a line in our program that we want to change, then we simply type in a new line which has the same line number. And the new line will replace the old one. If we don't want to type it in completely ourselves, then we can use the copy key to copy information from one of the old lines to form the new one. We can type any extra characters we want in the middle of the new line by just typing them at the right point, and we can delete characters as we copy them by pressing the delete key, which will always rub out the last character that was entered. So we've looked at adding and deleting and changing lines in a program that already exists. But of course, when we switch the machine on, no program is there. There's nothing to change. So we should look at a couple of the facilities that the Electron gives us, which make it simpler when we're entering new programs for the first time. Now, of course, when the computer is first turned on, there's no program in there. If we tried to list, we get nothing. There's no program to list. So if we're going to put in a new program, we could type in all the line numbers by ourselves. Start with line 10. We could say print. Line 20, we could say go to 20. If we list now, the two lines we typed in are now in the program. In fact, they're the only lines in the program. But it gets a little tedious if we have to type in all the line numbers ourselves, especially if we're copying a list from a book or from a magazine. So we can get the Electron automatically to produce the line numbers for us. I'll use a CLS command to clear the screen. And now I'm going to use an auto command. Auto asks for automatic line numbering. And as soon as we press return, you can see the line number 10 has been produced for us. As soon as we've entered a line of BASIC now, let's use print again and press return, then the next line is presented to us, ready with its number at the beginning. And we can continue to type in lines of BASIC. And each time we press return, a new line number is given to us. When we finish doing that, we use the escape key, that's at the top left of the keyboard, to say that we don't want any more automatic line numbers. If we list the program now, you'll see that the 3 lines we typed in now form the program, with the line numbers automatically put onto the front. I'll clear the screen again, and we'll take a closer look at the keyboard to see the significance of some of the words printed on it. Now, on the left-hand side of the keyboard, there are 3 keys which have special significance when we're typing programs in. Shift, CTRL, which stands for Control, and caps LK for capitals lock, combined with FUNC for function. Now we use these three keys in conjunction with other keys to obtain special effects. Let's see the result. Suppose we press the Z key. As the machine is switched on, we get a capital Z printed. If we wanted a small z, a lowercase z, we can hold down the Shift key while we press Z. So although the letters will normally give us capital letters, holding down the Shift key while we type a letter gives us a lowercase letter. But suppose that we wanted lowercase letters normally. Well, that's the function of capitals lock. If we hold down the Shift key and press capitals lock, this little light at the side goes out. This tells us that the computer is no longer locked into producing capital letters. If we press Z again, by itself, we get a small z. To get a capital Z, we hold down Shift and press Z, which gives us the capital letter. So, what about the function part of this key? Well, you'll see the words printed on the front of many of the keys on the keyboard. Instead of typing END in our program, we can hold down this key, the function key, and press Z. As you can see, the three letters of the word END appear on the screen. If we did it again, we'd get the same three letters repeated. So we can obtain any of these words printed on the front of the keys by holding down the function key while we press the key. X gives us proc. C gives us color. Now at the top of the keyboard, you see the number keys, from 1 up to 9 and then 0. And if we press number key by itself, we get the number that's printed on it. But above these keys are certain special symbols, punctuation marks and things like that. If we hold down the Shift key while we press the number keys, we get these special symbols printed at the tops of the numbers keys. And that happens whether or not we have caps lock turned on. Now over on the right hand side of the keyboard, there are four keys that we've looked at before, the four arrow keys. And these are rather different because they've got three symbols printed on them. Let's take the up arrow key. It has a pound sign and a curly bracket. By holding down the Shift key while we press the up arrow key, we get our pound sign. In order to get the curly bracket that's on the right hand side of the key, we use the control key, the one I showed you a moment ago. Holding down the control key while we press this key gives us the curly arrow. So these four keys that have three symbols on each, the one on the left, the pound, the underline, the caret, and this broken vertical line, we use a Shift key to get that effect. The symbols on the right, the curly brackets, the backward slash, and the wiggly line, we have to use the control key at the same time as pressing this key. Now we're going to take a short break there, and on the soundtrack of this video cassette, we'll record a short program. Now you'll be able to load this program into your computer if you connect the headphone or the line out socket on your video player to the mic in or the line in socket on the cassette recorder that you use with your computer. If you then play back the videotape while recording onto your audio cassette recorder, then the program will be copied across, and you can then load it into your computer in the same way that you did with the programs on the introductory cassette. Now you can use this program to practice what we've been talking about. Listing the program, changing it, adding lines, deleting lines. And look up in your user guide all the different statements and commands that we've discussed. Automatic line numbering, listing, clearing the screen. Because your user guide for your computer is where you're going to find all the details of the things that we're discussing on this videotape. After the break, we'll come back and we'll work on a complete program from scratch. Now, if we're going to write a program from the beginning, then obviously we have to know what it's going to do. And also we need to know how that program is going to do it, because the computer can't do anything unless we give it instructions. Now, if you're writing a program from scratch, then you'll have to work out with a pencil and paper, for example, just how the program is going to do its job. I have a slight advantage over you here because I've already written the program. So let's run through this, a small program to do some calculations, and see how it's built up, what the different parts of it are, and then we'll look to see how we code them in BASIC. Well, the first thing this program does is give us 3 questions that it wants answered: the distance traveled, the time taken, and the fuel used. And if you're going to ask questions of somebody, it's always good practice to say what units you want them in: miles, minutes, and gallons. Well, let's say we went 120 miles, so we enter 120 and press return. It now wants to know how many minutes it took. Well, let's suppose we were going quite fast and we took 80 minutes and that we used 6 gallons of fuel. As soon as we pressed return after the third answer, we get 4 lines of output telling us our average speed and our fuel consumption, and then average speed and fuel consumption using kilometers and liters. Well, that's what the program does. And if we think about it, there are 4 stages. In the first stage, we just present these 3 questions. Second stage, we accept the 3 answers to those questions. We couldn't see the third stage because that was the calculations involved in producing this set of answers. And the final stage was to print out the results, these 4 lines of results. So our program consisted of 4 separate stages. And Electron Basic has a facility which is very useful for dividing up our programs like this. And this is the ability to divide your program into procedures. The procedure is a bit of your program that will do one particular job. So in this program, we'll write one little procedure to print out the questions. We'll write another procedure to accept the answers that we type in. We'll use a third procedure to do the calculations, and then a fourth procedure to print out the final results. So we can see the main logic of our program in a very few statements. These statements. In the first 6 lines of my program, I've used 3 different statements. I've used a mode statement, I've used a proc statement, 4 of them in fact, and I've used an end statement. And just a word about this list command I used at the top. This program, the complete program, is now too long to go onto the screen at once. I knew I wanted to look at lines 10 through to 60 in the program, and so I used this form of the list command, list 10, 60. And that's just given me these 6 lines. So the main part of the program says proc questions, proc answers, proc calculate, and proc results. The 4 activities I talked about a moment ago. Proc questions says, go away to the part of my program called proc questions and execute all the statements you find in that part of the program. When you reach the end of proc questions, come back and go on to the next statement. So these 4 statements, these 4 proc statements, will execute the 4 different parts of my program, one after the other. Now the end statement is fairly clear. End simply means stop the program. When you've done these 4 things and finally printed out the results, stop the program. It's worth talking about this first statement for a moment or two, the mode statement. Now the Electron has 7 different modes. These affect the number of characters across the screen, the number of lines vertically on the screen, and the number of different characters that can be shown at a time. Your user guide contains a complete list of all the modes and their different effects. I've chosen Mode 1. This gives me 40 characters across the line and allows me to use 4 different colors on the screen at one time. And we'll see the effect of that in a few moments. So we'll start at the beginning by looking at the basic statements in the procedure I called proc questions. Now the coding we're interested in goes from line 70 to line 120. So if we list that, we see proc questions. At the beginning, line 70, we have def proc questions, which means define the procedure called questions. At line 120 here, an end proc statement, which tells us where the procedure ends. So all the coding between the def proc and end proc statements is the procedure proc questions. Now at line 80, we have a CLS statement, clear screen. That will set the whole of the screen to the background color, and you saw that was black. That's followed by 3 print statements, 90, 100, and 110. The first one prints distance traveled, miles. The second print statement, time taken, minutes. And the third print statement, fuel used, gallons. Now note that these 3 lines are all longer than can be got onto the screen. And so the text has wrapped from the right-hand side back to the beginning, back to the left-hand side. That doesn't matter. The program will still work perfectly well. It's just that when the program is listed, it has to break one line of BASIC across 2 lines on the screen. So print statements print information onto the screen. Here we've got fixed information. I put quotation marks at the beginning and at the end. So BASIC will know that that is fixed character information, and that'll be printed exactly as I put it into the program. Now here in each of the statements, I said tab. Tab 5,3, tab 5,5, tab 5,7. Because you'll have noticed that when we ran the program, these 3 lines didn't start at the beginning of the line, and they didn't start at the top of the screen. And that's because each of these print statements contains a tab. Tab 5,3 says start printing 5 characters from the beginning of the line and 3 lines down from the top. This one, 5 characters from the beginning and 5 lines down from the top. And the final one, 5 from the beginning and 7 down from the top. tab is extremely useful when we want to print some information at a specific point on the screen. We can say exactly where on the screen each of these pieces of information will be printed. Well, that's all procedure proc questions does. Simply prints out those 3 lines in the middle of the screen. Let's look at the next procedure, the one that accepted the answers we typed in. The next procedure goes from line 130 to line 170, and there it is, proc answers. Again, def proc at the beginning, end proc at the end, telling BASIC that this set of statements is the procedure called proc answers. And this contains 3 input statements. Whereas the print statement took information from your program, put it onto your television screen, the input statement allows you to type information on your keyboard and it'll go into the program. I've used tab again in this input statement. 34.3, 34.5, 34.7. And you remember the 3 numbers I typed in were over on the right-hand side of the screen. So I've used tab to make sure that when I type my input, it goes into the right place on the screen. But what are these things? Miles, minutes, and gals? Well, they're in lowercase letters. And I said a little earlier that those will be used for things that I'd invented, names of my own. Well, miles, minutes, and gallons are what are known as variables. I said to BASIC, in this first statement, I'm going to type in a value because I put input. I'm going to use that value later in the program. The number of miles I traveled is a number I'll need in my calculations. When BASIC finds a name like this that it hasn't seen before, it assumes that I want to keep a value in my program. In this case, a number. And so it allocates me a little bit of memory and calls that piece of memory miles. We'll see later that I'll refer to that name, miles, again. And BASIC will be able to give me back the number I typed in. So after this procedure, there are 3 pieces of memory. One called miles, one called minutes, one called gals. And the 3 numbers that I input here, 100, 50, 7, or whatever the numbers are, will be placed in those 3 pieces of memory called miles, minutes, and gals. And that's all proc answers does. It allows me to type in my 3 numbers and saves them in memory in locations with those 3 names. And of course we'll use those names and the variables they refer to in my calculations. Well, there's proc calculate, def proc, and end proc as before. The statements in this procedure, however, haven't started with one of these basic keywords. They've started with our own names. Because here we're doing calculations, depending on the numbers we typed in, and the answers to those calculations are going to be placed in other parts of memory. If we take the first one, I've written 60, just the number 60, and then an asterisk, meaning multiplied. The name miles that you saw a moment ago, the name minutes, again that you saw a moment ago. An equal sign, and on the left, another of my names, MPH, standing for miles per hour. This means take 60 multiplied by the number of miles, divide by the number of minutes. The number of miles, BASIC can find because it's in that piece of memory it called miles. Similarly, minutes is in another piece of memory and BASIC knows its name. So it'll take these 2 of the numbers we typed in and the 60 and do this calculation. When it's got an answer, it'll go and set up a new piece of memory and call that piece of memory MPH, and it'll put the answer into it. So after the statement at line 190 has been executed, miles and minutes will still contain the numbers that we typed in, but now we have a new variable called MPH, and that's got a number in as well, the result of that calculation. And line 200 is very similar. We've taken the number of miles, divided it by the number of gallons. Again, BASIC recognizes these two names as names we've used before. The answer to that is put in a new variable called MPG. Because this is the first time we've used the name MPG, BASIC knows that the result has to be put into a new area of storage with that name. And then similarly, we've calculated kilometers per hour and liters per 100 kilometers. Same sort of calculation, except that here, to make things clearer, I've used brackets here and here. It's often useful to use brackets when you're writing a complicated calculation because it makes it much easier to read and easier to understand. So when we finish this procedure, we've done all these calculations and we're ready to print the results. I'll use a slightly different form of list command to list this final procedure. I know it starts at line 240, but it goes on to the end of the program. If I say list 240, comma, and then no second number, then BASIC will list my program from 240 up to the end. And there's proc results. Def proc results, end proc. It's a little bit complicated because these lines are rather long, but I have 4 print statements. As before, I've used tab to make sure that I print exactly where I want on the screen. This time it's position 2 from the left, and line 9, line 11, line 13, and line 15. Now in each of these print statements, I'm printing 2 things. Let's take 250 as an example. I'm printing the average speed, MPH, and a colon. And that's a constant value with quotation marks around it. I then have a semicolon, and that says I'm going to print something else after this, and I want it to follow immediately after. What I'm printing is MPH. Remember, that's the name of one of my variables, where I put the result of one of my calculations. So BASIC prints out this constant value, average speed MPH, and then looks in the piece of memory that it's given the name MPH to, and will print out the number in that memory. Similarly, line 260 prints fuel consumption, MPG, followed immediately by the value of my variable, MPG. Average speed, kilometers per hour, fuel consumption, liters per 100 kilometers. So the final procedure in the program contains only 4 print statements, each printing one constant value that will be the same every time, and then whatever number is in that memory location, the result of my calculation. The program does basically what we've asked it to. It asks us questions, it allows us to type in answers, it does the calculations, and prints out the results of those calculations. But there are some improvements we could make to the program. 2 of them immediately spring to mind. At the moment, when the program has done one set of calculations, it stops. We'd like it to go on and do another set and another set until we tell it we don't want to do any more. And the other change we should make is, well, we could put some color in it. The Electron is a color computer after all, and white writing on a black background isn't very colorful. So let's put in some changes to this coding to do both of those things. Here's the beginning of the program again, and these 4 statements, the 4 proc statements,
are the ones I want to repeat over and over again. I'll do that by putting a new line between 10 and 20 and another new line between 50 and 60. For line 15, I'm going to say repeat. And for line 55, I'm going to use until. Now repeat and until together form a loop. They make our program go round and round, repeating until something is true. So this is an easy way to repeat those 4 statements over and over again until we stop the program by another method. Now I'll start by using repeat until false. Well, false will never be true, so this will repeat forever. Let's just list those statements to make sure that they've gone in correctly. Well, as you can see, lines 15 and 55 have gone into the right place, and so my repeat until false goes around my 4 proc statements. Well, let's run the program again and see what happens. And I'll use function key R to run the program. 120 miles in 80 minutes using 6 gallons. Well, yes, the program has gone round to do it again, but it didn't stop for long enough for us to be able to see the results. I'll press escape to stop the program at this point. We'll go back to that listing and look to see what mistake we made. And if we look back at the coding, we can see what's happened. As soon as the results have been printed, we come to this until false, and our program immediately goes back to here, clears the screen, and asks the questions again. So we need some way of pausing the program after proc results before we go back to repeat the whole procedure. While we're doing that, we can change this. We can remove false and put in some more meaningful test so that we have a choice as to whether the program continues or stops. Well, I've changed the program slightly, as you can see. My until statement at line 55 now has something different after the word until, and I've put in a new statement at line 54, an input statement. I said input, and then I put quotes around another, yes or no. Now, I can print things with an input statement by putting them in quotes after the word input. Here's the name of a variable, $ANS, for answer. And this $sign at the end of it is very important. All the names we've used so far for our variables, ones to hold numbers, have just had letters in, and some digits. By putting a $sign on the end of a name, we're telling BASIC that ANS is not to hold a number. We're just going to put a string of characters into it. Anything from 1 character to 100 or more characters. The extra quotation mark here is to give me an extra blank line. The until statement makes a test. Until answer $, that's the value that was typed in there, is equal to the constant NO, no. Well, let's run it and see what the effect is. We'll use the same values again. 120, 80, 6. And here you see the effect. We've stopped after printing the results, and we have this extra line. Another, yes or no. Well, let's type in yes and see what happens. As we type it, the letters appear. When we press return, we have the original questions back. Let's put 12, 4, and 2. Again, the results are printed. Another yes or no is printed again. This time, if we answer NO for no, our cursor returns with that little arrowhead that tells us our program has finished. So we're now able to control the execution. We can go round and round as many times as we want until we answer no to this question. Now we've recorded this program onto the soundtrack of the videotape in the same way that we did with the first one. And this program contains a lot of new things, and I think it's very important that you load it into your own machine and go through and look at the coding that we've discussed. And as you do that, and as you run the program, you'll find that I've added some extra statements that'll give you some colored output instead of the plain black and white output. After that program, we'll look at some graphics. I've got a little program here that draws a graph, depending on numbers that we type in. Let's have a look at the program first to see what it does, and then let's look at the basic coding that achieves that effect. It starts by asking us how many points we want. Well, let's say 5. There's a short pause while the screen is cleared. Then we get a vertical line and a horizontal line to act as axes of the graph, and it asks us for a value for the first point. Well, let's say 100. And it's drawn a line and goes on to ask us for the next point. If we make that 500, 600, 20, 900, we can see that for each value we've put in, a line is drawn along the graph, reaching up or down to that point. So, what are the statements necessary to get the Electron to draw lines on the screen? Well, this program uses 3 procedures. Proc setup, which finds out how many points are to be drawn and sets all the colors ready. Proc axes, which draws the 2 lines to form the axes of the graph. And proc input, which takes our input as we type it in and draws the lines. Before we look at the actual basic statements which handle graphics, we should look to see how the Electron thinks of its graphics screen. We've seen how the complete screen is divided up for text, and this is how the Electron looks at it for graphics. From left to right, there are 1,1280 points, numbered 0 to 1279. 0 is on this side, and 1279 on this side. Vertically, it thinks of points 0 to 1023. 0 at the bottom, unlike with text, 1023 at the top. So we can identify a particular point anywhere on the screen by a number in this direction from the left and a number in this direction upwards. For example, this point here has numbers 200, 800. It's 200 in from the left and 800 up from the bottom. This point is 1200 from the left and 300 up from the bottom. Well, here's our procedure proc setup, which starts to use those graphics coordinates. Here we have 2 VDU statements. VDU24 and VDU28. And these divide our screen up into two windows. VDU28 says which part of the screen should be used for text. VDU24 says which part of the screen should be used for graphics. And the four numbers here define how much of the screen is the graphics area. And these numbers are the numbers we've just been talking about, the graphics coordinates. Now you'll need to check both VDU24 and VDU28 in your user guide so that you know exactly what each of these numbers does. Another statement in this procedure, which is to do with graphics, is this one at line 150, G-call. We've used color to set the color of text. G-call is used to set the color of the graphics that we're going to draw. Here I've said, draw my graphics in color number 2, whereas my text is set to draw in color number 1. And the third statement in here, which is to do with graphics, is this one, CLG. CLS clears the text screen. CLG will clear the graphics screen. So this area, defined by the VDU24, will be cleared by this clear graphics statement. Here's the next procedure, proc axes. And this uses two new graphic statements, move and draw. The numbers we specify in move and draw statements are these graphics coordinates we've been talking about. Move moves us to a position on the screen but doesn't draw anything. It doesn't make a mark on the screen. The draw statement draws a straight line from the last place we visited to the point described by these two numbers. So move 79,1023 will move to a point right up at the top of the screen, but well over to the left-hand side, but won't make a mark on the screen. Draw 79,100 will draw a line vertically downwards to the point whose numbers are 79,100. The second draw will draw a line from the end of this first line to the point 1279,100. And that'll be a horizontal line going across to the right-hand side of the screen. And those two draw statements draw the two lines of the axes that we saw before. And here's the procedure proc input, which does most of the work. Right in the middle of the procedure we have this draw statement. Having input the value of the point into the variable called point, we're using the variable x to measure how far along the line we are. And then we draw to the point x, point plus 100. We've put in an extra 100 here because our horizontal line wasn't at the bottom of the screen, it was 100 up. So we're having to move everything upwards by 100 points. So we go around this using this for next loop, which I'll mention in a moment. Each time we input a number into the variable point, we then draw a line from the end of the last line to the position for the new point. And here we have a for next loop, which very simply will make sure that we go round this p times. For I equals 1 to p means that all this coding will be executed p times. And remember, p was the number of points we wanted to draw. We've only had time on this videotape to show you a small proportion of the things that are in Electron Basic and the sorts of programs that you'll be able to write. But if you look at the coding that we've recorded on the soundtrack, look at the techniques we've used, then I'm sure that will help you to learn how to use your machine yourself. And in later tapes, we hope to show you some more techniques. We've recorded, as I say, that last program after this. Go through it, look, each of the individual basic statements up in your user guide to learn how to use them. And with practice, you'll be writing programs like this one.